Hi everyone, my name is Yichu, and today our team is very excited to share our findings from our final presentation. So last year, all three stock major indices experienced over 35% correction in March. And more importantly, now retail investor participation has accounted for as much volume as mutual funds and hedge funds combined, which is quite insane. Therefore, our team was wondering if there's a way to quantitatively predict stock market performance in the consumer staples sector with behavioral data. And here's a snapshot of our team. And today, Cynthia and Eileen will talk about data retrieval, and then Alan and Hannah will talk about modeling. Then I'll wrap up with some conclusion and our key findings. Without further ado, I would like to pass on to Cynthia.
Thank you, Yichu. To capture the relationship among stock market variations and COVID-19 related behavioral responses, we decided to look into the following factors. First, starting with the predicted value, we will be pulling data from the consumer staples sector. Then explanatory variables are health-related statistics and behavior-related data. To fit the purpose of our machine learning approach, we perform data cleaning by upholding four key aspects: relevancy, consistency, completeness, and regularity.
The reason we chose these variables was because we're exploring the stock performance in consumer sector only. We like to get the data that's not only COVID related, but also human related. Before we started fitting the models, we created correlation graphs between each variable and the stock market price. For COVID data, the number of new cases and death, we surprisingly found a positive correlation between them and the stock price. For behavioral data, we did not observe obvious positive correlations between them. Lastly, we failed to observe any trends between COVID keyword searches and the stock price.
We did 5 models in this project. Before making any models, we performed the variable selections shown here. Our first 3 models are based on linear regression. In the time series model, we incorporated the stock price of the previous 2 days as the primary time series factors. Now we use the selected variables to make an autoregressive model. With the same set of variables excluding the 2 time series features, we made a linear regression model. We then made a ridge regression model with a shrinking factor determined by the grid search cross-validation over a 0.1 to 10,000 50-element log space. Next is the random forest model. We use the grid search cross-validation to fine-tune the max features hyperparameter. From this figure, we can see that 11 max features will yield the best cross-validation R-squared. We then build a random forest model with the best hyperparameter from the 5-fold cross-validation. Similar to the steps we did for the random forest model, we use 10-fold cross-validation to estimate the best complexity parameter and use it to build a cart model. The final model can be visualized in this figure.
This table summarizes the test set performance of our models. Our time series model is very compelling in predicting stock prices of the consumer staples, with an OSR square of 0.984. Other models all have OSR square around 0.6. It can thus be inferred that the stock prices are stable even during the pandemic, and the prices of the previous days are the dominant predictors. The changes in COVID cases and public behaviors, like online searches, do not show significant impacts on the stock prices. To get a sense of model volatility, we use 5,000 bootstrap datasets to estimate the variance of bias of the reported test set performances. This figure shows the OSR square of linear regression model. Both subplots appear normal, and the second plot centers around 0. This is a general trend for all metrics and indicates that the biases of the reported values are likely small. This last table shows that all the biases and standard deviations are relatively small. Therefore, our models are expected to have consistent performances over different sets of data.
Now I'd like to say a few things to wrap up our presentation. So one of the most important lessons we learned here is to not oversimplify, especially in a situation like this. For example, in our case, it's almost counterintuitive to see that the severity of coronavirus almost have a positive relationship with our stock performance. And that further proves the forward-looking nature of the stock market and investors' expectation for strong and speedy economic recovery. Other factors like unprecedented stimulus check introduced by the Fed for people and businesses under impact can also contribute to the historical run. And thank you. That concludes our presentation.